Hey everyone! Welcome to day 4 of our 30 days of Creo Modeling Challenge for Beginners. Today we're going to create something a bit more interesting, the shaft support block. This model will give us a chance to practice the basics again, but also explore a couple of new features along the way. So don't worry if you're still learning. I'll guide you step by step. Let's jump into Creo and start modeling. Here's the 2D drawing for our Day 4 model, the shaft support block. The distance between the two mounting holes is 170 millimeters, with each hole having a 16 millimeter size and an R20 arc on the ends. The larger outer arc has a 45 millimeters radius. The base plate is 15 millimeters thick, and the central hub is extruded up to 40 millimeters. At the center, we have a counterbore of 60 millimeters. With a drilled hole of 35 millimeters inside it. The counterbore depth is 10 millimeters. There's also a 15 millimeters side hole, positioned 20 millimeters from the top edge and 15 millimeters from the right edge. All right, let's open up Creo and start building this U-clamp step by step. Let's start by creating a shaft support block using a 2D drawing. First, open the sketching environment by clicking the New tool. Make sure the Part option is selected in the Type area and Solid in the subtype. Then name the model Shaft Support Block. Uncheck the Use Default Template box and click OK. In the next, select MMNS Parts Solid Abs and hit OK. Now, click on the Sketch tool in the Datum group. Select the top plane and confirm with Sketch. Switch the view to Normal to using the Sketch View tool for a better orientation. Use the Circle tool to draw a circle at the origin. Then exit the tool by pressing the middle mouse button. Next, draw a line from the circle with the Line tool and exit it with pressing middle mouse twice. Mirror this line across the horizontal axis. Create a 3-point tangent arc connecting the parental and mirrored lines. Draw another circle at the arc origin. And set tangent relations between the lines and arcs. Select all sketch parts on the right of the vertical axis, mirror them across the vertical axis, and delete the unwanted entities by using the Delete Segment tool. Now dimension the arc radius to 45, this arc radius to be 20, the circle diameter to 16, and the distance between the centers of the arcs to 170. Finish by clicking the green tick to exit the sketch. Click the Extrude tool and set the model's orientation to standard. In the Depth area, make sure the Variable option is selected, then enter 15 as the depth value. Confirm by clicking the green tick in the Extrude tab. Click the Extrude tool and select the top face of the base model. Change the orientation to Normal to by clicking the Sketch View tool in the In-Graphic toolbar. Next, expand the arrow beside the Circle tool, select Concentric Circle, and click an arc on the base model to create a circle. Exit the tool by pressing the middle mouse button. Now, select the Rectangle tool and draw a rectangle over the circle. Exit again with the middle mouse button. Click the Mirror tool and choose the vertical axis as the mirror line. Use the Delete Segment tool to remove unwanted parts. Add dimensions. Set 75 for the distance between the origin and the rectangle line, 10 for the space between rectangles, and 10 as the rectangle width. Exit the sketch by clicking the green tick. Change the model orientation back to standard. In the Extrude tab, ensure the variable option is selected in the depth area and enter 40 as the depth value. Click the green tick to confirm. To create a hole, first create a datum axis. Click the Axis tool in the Datum group of the Model tab. Make sure the CSY's display checkbox is checked in the Datum display filters. Select the Y-axis as the reference and place the axis along it. Click OK. Next, select the Hole tool and pick the top face of the second extrude feature. If the placement panel isn't open, expand it. Choose Coaxial from the Type drop-down. Then select the Datum axis while holding the Control key. Under the Hole tab, choose the Drilled profile and enable Counterbore. Switch to the Shape tab. Select to Next for depth and enter the Counterbore diameter as 60. Counterbore depth as 10. And drilled hole diameter as 35. Click the green tick to confirm. Click the Hole tool again and place the hole on the right planar face of the second extrude feature. In the Offset reference field, select two edges by holding the Control key. Set the vertical edge offset to 15 and the horizontal edge offset to 20. Enter 15 for the hole diameter in the Size field. And choose the Through All option for depth. Confirm by clicking the green tick in the Hole tab. Select the Chamfer tool and apply a 1.5 mm chamfer to the circular edges on both the right planar face and the back planar face of the model. Once the chamfers are set, confirm by clicking the green tick mark button in the Edge Chamfer tab of the ribbon. Now we'll add the round finish using the Round tool. Select the Round tool, enter a radius of 10 in the Radius field, and make sure the Profile drop-down is set to Circular. Then select the edges you want to round. Once all edges are selected, confirm by clicking the green tick in the Round tab. That's it for day 4. We just wrapped up modeling the shaft support block. Awesome job sticking with it. Every part you model is sharpening your Creo skills. Remember, it's totally fine if it's not perfect yet. This 30-day challenge is all about practice and progress. Up next, on day 5, we'll tackle a new model with fresh techniques to learn. Stay consistent, and I'll see you in the next one. If you found this helpful, don't forget to share it with your friends and hit that subscribe button so you don't miss the upcoming tutorials. Catch you soon!